Now, since we have already studied addition and multiplication of the vectors, so in today's class we will do some problems related to the addition, multiplication and all the algebras of. So today our first problem is, suppose we have two vectors. Suppose numericals. First one, find the magnitude and direction of the following So this is your vector A. You have to find the magnitude and direction of this and this. So the magnitude of this will be, so this, the vector A has two components, 3i plus 4j. This is along x-axis, this is along y-axis. Its component along x-axis is 3 in magnitude, and along y-axis its magnitude is 4. So it is, suppose this is your xy axis, it means 3i means 3i. This is one unit vector, 1, 2, 3. And 4j means along the y axis, it has components 4, 1, 2, 3, 4. It is 4j. And the vector, this is the vector A. It has two components, 3i, 4j. So in order to find the magnitude of A, this is the x component, this is the y component. So that magnitude will be obtained as magnitude of A. We already know that the magnitude of will be given by ax square and ay square, x component square and y component square, and the angle, say the angle theta, which we make in the x-axis, theta will be ay by ax, so it will be ay by. So in this way, this can be found the magnitude. So the magnitude of A will come out to be 3 square plus 4 square. This will be 9 plus 16, that's 25. Under 25 will be 5. And the angle will be obtained by ay by ax, that is 4 by 3. So we will take out this, work out this in the decimal order, and from the table you will find the angle of this. From the table you will find tan theta is this much, then for which theta this refers. So this is the way to find the magnitude direction. Similarly, we can find the magnitude direction of vector B will be also B, magnitude and direction of B will be simply magnitude of B will be 2 square plus 6 square, 4 plus 36, that is 11, 40. And the directions, this angle again divided by theta, this will be 6 by 2, that is 3. So in this way we can find the magnitude of the direction. Now the next problem. Now find A dot B, A cross B, where A and B are the same. So A dot B means 3i plus 4j times dot product 2i plus 6j. So it will be 3 2s are 6 I dot I, and we know that I dot I is 1, so that will be plus 3 6 18, but I dot j, and I dot j is 0, so that will be 0. 4 2s are 8, j dot I is 0, so it is 0. And 4 6 24, j dot j is 1, so it is 9. The product of A dot B is 30. Now, if you want to find the A cross B, it will be here. A cross B here. So, the next problem. So it is 3 2s are 6. I cross I. 3 6 are 18. 4 2s are 8. J cross I. 4 24. J cross B. So it is I cross I is 0, I cross j is k, and j cross I is minus k, so it will be minus 8k. J cross j is 0, so it is 10k. The A cross B has a magnitude 10 along the y-axis. So these are some examples of how to solve, how to take dot product, cross product. Now if you want to find the angle between the two vectors, find the angle between the vectors the same, say 3i plus 4j, and b is 2i plus 6j. Now we have to find the angle between the vectors a and b. So we know that A dot B is AB cos the angle between them. So one way is to find the angle is to find the cos theta. So the cos theta will give you A dot B by okay. And this is the magnitude of A, this is the magnitude of B, and this is the dot product of A dot B. So A dot B we have just found out, that is A dot B was 3 to the 6 I dot I, that is 1, 6, I dot J 0, J dot I 0, J dot J 24. So it is and the magnitude of A is 3 square plus 4 square the root, that will be 5. And the magnitude of b will be given by 2 square plus 6 square. 2 means under root. So this value, after solving this, take the root, multiply by 5, divide by 30, you get some result answer in the decimal number. Take from the table you find for which angle this number refers. So you get theta as, and the theta comes out to be 18.43 degrees. So this is one way to find the angle between the two vectors. This can also be found by taking cross product. If you take cross product here, this will become sine theta. So in that case, this will be equal to a cross b sine theta, and sine theta is equal to a cross b, the magnitude of a cross b divided by the magnitude of k cross b is given by ab sine theta. So since we have to take the angle between the vectors, we take only the magnitudes of this. So sine theta is equal to a cross b by ab, and a cross b, which we have already done, a cross b means I cross I 0, I cross j k, so it is 18 k, j cross I 0, j cross j is 24 minus 20. Sorry. Okay. So it is j cross I will be minus k, so it is 8 k, and j cross j will be 0, so it is 10 k, its magnitude is 10, so it is here 10, and a was found out to be, magnitude of a was, we have just found it's 5, the magnitude of b is under 50. So the another way of find the angle between the two vectors is used by using this method also. You can find the angle. This again will give you the same angle, that is 18.43 degrees. There is one more way to find the angle between the two vectors, and that is suppose we have two vectors A, which makes an angle, say theta 1 with x-axis, and vector B, which makes an angle theta 2 with the x-axis. So the angle between the vectors is theta 2 minus theta 1. And tan theta is given by, tan theta will be given by 4 by 3 ay by x. Similarly, the tan theta for this will be 6 by 2 by bx. So tan theta we know, tan theta 1 is 4 by 3, tan theta 2, then which this makes 6 by 2. Now we have to find the angle between the two vectors. So we require tan theta 2 minus tan theta 1. So it is using the trigonometrical formula, we can write tan theta 2 minus tan theta 1 by 1 plus tan theta 2 tan theta 1. Substitute the values of, you will get the answer, the angle. This is 4 by 3 minus 6 by 3, 6 by 2. Oh. 6 by 2 minus 4 by 3, 1 plus 6 by 2 Work out this and get the answer. Angle between the two vectors. This suppose theta 2 minus theta 1 is alpha, so you get tan alpha from this. This will also give you the same answer. No. Okay. What's the meaning of geometrical meaning of A cross B? A cross B means the value of A cross B, the magnitude of A cross B will be given by, or okay, A cross B will be given by A B sine theta, and this will be a vector. Suppose this is pointed along unit vector n, where n is perpendicular to the plane formed by A and B. So if this is vector A and this is your vector B. So the cross product of A cross B will be along this direction. Using this right hand rule formula, put your right palm on the first vector, rotate the fingers to align around the second vector to smaller angles. Then the thumb will point the direction of A cross B. So the vector A is first vector, right palm, rotate fingers to align around the second vector, the thumb will point outside the blackboard. So the direction of A cross B is this way. So A cross B can be written as A times B sine theta, and B sine theta is, if this is theta, this is B sine theta. So if you form a parallelogram of this with these two vectors, then draw A here and so this is the height of the parallelogram. This is the base into height, and the base into height means area. So it is the base into height. This is magnitude of the area, and it's the direction of area. We know that the area is a vector quantity. So the area has a direction perpendicular to the plane. So this, the area of this parallelogram is of these values having the direction of areas. So if you check, the area of this plane will be towards the observer, and the area of that plane will be towards that. So, okay. So the meaning of A cross B is equal to the area formed by the parallelogram with the vectors A and B. Now suppose we have A cross B dot C. What's the meaning of A cross B? A cross B may, suppose this is a vector, and that vector is, say, denoted by D dot C. So the D will be along this direction, and C is a vector. Suppose C is in the third dimension. So this will gives you, oh, suppose we have to, suppose this is your so okay. Suppose this is your vector A and this is your vector B and this is your vector C. So the A cross B will be on, and C is, this is A cross B and C is, this is A, this is B and this is C. Suppose this is C. This is A, B and C, three vectors. Now A cross B will be perpendicular to the plane formed by, so this D will belong to this one, C. So D dot C means D C cos of the angle between the two vectors. Which means the angle between D and C. That is the component of C along D. So this gives you this is the area into height. This is the area formed by A cross B. This is the area and this is the height. And of course this is the volume. The volume of the parapet made by the three vectors A cross B dot C. If A cross B dot C is 0, it means its volume is 0. It means if C is along the dash is perpendicular, if D dot C is 90 degree, means that C is collinear in the coplanar vector. If it's coplanar, then this volume will be 0. So just volume, because this gives you the height. So if this is, so C is outside the blackboard and D is like this. So it is D, C is here and D is here. So it is, and the angle between them is theta. So D, C cos theta means the perpendicular. This gives you the height. And it means that A cross B dot C represents the volume of the parapet made by the vectors A, B and C. Okay. Now, one more problem for today. Then we'll finish this. If A and B are two vectors, if A and B two vectors such that their resultant is perpendicular on A. and in magnitude equal to A, and find the magnitudes of E. So this is your question. So if A and B are two vectors and the resultant is perpendicular on A, which means if suppose this is your vector A, and the resultant is perpendicular on A. So the resultant is, this is the resultant. And the magnitude of resultant is equal to the magnitude of A. So the length of this will be equal to the length of this. So, and this is the resultant of A and B. So B must be somewhere here. So that this is B, this is A, so this is the resultant, and this is 90 degree. We know the resultant, magnitude of resultant can be obtained by A square plus B square plus 2AB cos of the angle between A and B. This is the cos of the angle between A and B. Also we know that the angle which the resultant makes can be obtained by B sin theta by A plus B cos theta. So in this problem, this value is given. So this is 90 degree. And this is tan 90, B and tan 90 means infinite. This is 1 by 0. So it will be 1 by A plus B. So A plus B cos theta is equal to 0 means B cos theta is equal to minus A. So now we have to find the B here. So the next step is to use this one, and it is given that this the magnitude of R is equal to the magnitude of A. So it is, if this is A, so it becomes A square, removing the square root and taking the square on the left hand side. So it's A square plus A square plus B square plus 2AB cos theta. But we have here found out that B cos theta is equal to minus A. So the B cos theta will be minus A here. A square plus B square minus 2AB square. This is so it is B square minus A square minus, so B square is 2A square. Take the on the left hand side, this will become plus, so A square plus A square, 2A square, and B will be the root 2 times. Okay. So all this for today's problem, and we have already done a lot of works in vectors. Suppose that the vectors is finished. Oh, one thing is remains. Okay, one thing I want to explain to you is that if you take the cross product of two vectors, A cross B, this is C. The C is a vector, and this vector is perpendicular to the plane formed by A cross B, the vectors A and B. So this type of vector is called axial vector. Axial. This is adapted along this vector is so the C is here. The C is along the axis, that's why it's called axial vector, and these are called polar vectors. If you change the direction of multiplication B cross A, you change the rotate, this will be minus C. So this is the if you take, instead of taking A cross B, if you take B cross A, this will be minus C. Again directed towards the axis, but the axis is opposite. B cross A means inside and A cross B means. So this is the meaning of axial vector. So today we have finished. I finished your vectors. Thank you.